Hi, welcome back to Leetcode. So in this video, I'm going to discuss uh, third problem from today's weekly contest 474. The problem name is minimum time to complete all deliveries. So what is the problem statement? Problem statement is that you are given two integer arrays of size 2. One is array D, another is the array R. So for array D, we have two things. One is D1, another is D2. And similarly for array R, we have two elements. One is R1 and another is R2. So two delivery drones are tasked with completing a specific number of deliveries. Drone I must complete DI deliveries. Drone I must complete DI deliveries. Okay, so that means we have two drones. One is a drone 1 and another is drone 2. So in drone 1, we have to complete suppose D1 number of deliveries, and similarly for drone 2, we have to complete D2 number of deliveries. And each delivery task exactly 1 hour. Okay, takes exactly 1 hour, and only one drone can make a delivery at any given hour. Okay, so that means we can't actually use like two drones at it simultaneously. Like we can actually use D1 or D2, right? Now, additionally, both drones require recharging at specific intervals during which they cannot make deliveries. So for drone I must recharge every RI hours. Okay, and return an integer denoting the minimum total time in hours required to complete all deliveries. So let's see the example one. So we actually have two drone one and drone two. So first drone, how many deliveries I have to do? First drone I have to do 3 deliveries, and for the second one I have to do 1 delivery only. And recharge time for the first drone it is actually 2, and for the second one it is actually 3. So drone 1 will be recharge at time 2, 4, 6, 8, this interval, right? Interval at 2. Similarly for drone 2, it will be actually recharge at interval of 3, 3, 6, 9, 12 in this order, right? Now I have to do 3 deliveries for the drone 1 and 1 delivery for the drone 2. Now we have to find out the minimum time T required to satisfy all these two conditions. That means we have to deliver 3 deliveries for the drone 1 by drone 1 and 1 delivery by drone 2. Now we have to find out what is the minimum time T. We can actually do that. Now, what is the brute force approach we can think here? So first of all, I will see that, okay, by using T is equal to 1 at the time T is equal to 1, can I actually do that or not? Is it possible to deliver all those deliveries which actually by using by drone 1 and drone 2? Now, if it is already satisfying the condition, so this will be our answer, because I am actually iterating from 1 to infinity. Infinity means less, the next greater number, right? So that's why, if because I am iterating from left to right, so that's why whenever actually I found any answer, possible answer, so that will be our answer. That is the minimum time. Because suppose I found one answer, possible answer with 1. Next, I will go to check with 2. Suppose this is actually also satisfied. So what is the minimum answer? Minimum time utility is 1. So that will be our answer. Yeah. Now find out this answer for the example 1. So D is equal to, for the example 1, 3 and 1. And for the next recharge time, it actually is for 2 and 3, right? Suppose I assume that I can complete with T is equal to 4. Suppose I am saying that I can actually complete this condition within time 4. Now, how many total uh, delivery actually I can do by using the drone 1? So that actually is total 4 hours. How many deliveries I can do by drone 1? Drone 1, that will be 4 minus 4 by 2. Why 4 by 2? Because total time actually is 4, right? So how many times that drone 1 will be charged? That will be at the time 2, and that it will be 4. So they mentioned that we can't actually use the drone to delivery uh, at this time 2 and 4. So how many number of time it will be raised? So that will be 2, 4 by 2, because the frequency it is 2 and total time is 4. So 2 times it will actually charged. So total how many deliveries I can do? That is 4 minus 2. So 2 deliveries I can do by using the drone 1. Next, how much deliveries I can do by using the drone 2? There is total deliveries I can do 4 hours. They mention that at 1 hour I can deliver actually only one item. So that's why 4 deliveries I can do because the time is 4. Now how much actually I can do? That is 4 by the rest. It will be recharged. So that is 4 by 3 because it will be t is equal to 4. And how many times this drone 2 will be recharged? That is the time is equal to 3 only, right? So that is actually 4 minus 1. So 3 times I can actually deliver by using a drone 2. So I have to see now that is it possible to deliver 3 number of items by using the drone 1 and 2 number of delivers by the drone 2. So you can see that how many deliveries maximum I can do, that is actually 2. And how many maximum deliveries I can do by using a drone 2, that is actually 3. So this is actually possible by using drone 2, it's satisfying that condition. But for the drone 1, you can see that maximum I can do 2, but actually I need actually 3. So this is not possible, right? So that's why t is equal to 4, it is not possible. Next, go to the actually t is equal to 5. So by using drone 1, how many deliveries I can do? 5 minus 5 by 2. This is clear, 5 by 2 because this 2, it will be recharged at the time 2 interval of 2. So 5 by 2, it will be actually 2. So 2 times it will be recharged at the time t is equal to 2 and another it will be 4. So 3 deliveries I can do by using drone 1. Similarly for the drone 2, how many deliveries I can do? 5 minus 5 by 3. So that is 5 minus 1. So 4 deliveries I can do by using a drone 2. Right? So, but how many actually, what is the condition? That I want to deliver 3 items by using a drone 1 and 2 items by the drone 2. So, can I actually do that? Yes, you can see that I want to complete 3 delivery. Actually, I can actually do the 3 delivery. And here actually I want to do 2 delivery. Actually, I can actually deliver 4. Right? So that's why it is actually greater than 4 greater than 2. So I can do that. Here also 3 greater than 3. So I can actually do that. Now, this is actually true. This is actually clear. Now it is possible that both are actually like both will be. This is case when actually only one drone actually is recharged and another is actually working, right? But it may possible that suppose at t is equal to 6. So at t is equal to 6, which drone can actually use any drone out of these 2 drones? Let's see. So first drone I mentioned that it will be recharged at the time 2, 4, 6, 8 in this order. Next for the drone 2, when it will be recharged, it will be recharged at 3, 6, 9, 12 in this order. Now for the t is equal to 6, can actually use any drone to deliver? No. So that's why this is the time when actually all will be recharged. Both of the drones will be recharged, right? So I can't deliver. So what is the time when actually I cannot use any one of them? That is 6, 12, 18, 24 in this order, right? That is the time when actually both the drones will be recharged. Now, how many deliveries I can do now? So that means total time actually I can have actually suppose t number of deliveries I can do because this is the time t. T hours mean t deliveries I can do. Now how many deliveries time when actually I cannot use any one of them drone. So that will be t by LCM of suppose our recharge time of R1 and R2. Clear? This is clear. This is time. This is actually the deliveries I can use. This is clear. Actually, I am taking the LCM, least common multiplier. That is actually the number that actually divisible by both the numbers, right? Like you can see that 6 is divisible by 2 and 6 is also divisible by 3. So I have to see that is there any such time when actually I cannot use any one of them. So that's why I have to do that. So this is the total time. This is total like t minus t by LCM of this R1, R2. It actually gives us the total derivative I can do. Right, this is clear. Now I have to see that without any like I can actually use the drone 1 at how many times? That will be t minus t by R1. And this T2, the drone 2, I can deliver how many times? t minus ty r2, and total delivery I can actually do, that is t minus ty LCM of r1 comma r2. This is clear. Now what is the, if I want to satisfy that, check that can actually deliver within t hours or not. So what should be the condition? That I want to deliver D1 delivery by using a drone 1 and D2 deliveries by the drone 2. So D1 should be less than equal to T1 and D2 should be less than equal to T2, right? This is clear, because how many deliveries I want to do by using a drone I, that should be less than how many maximum actually deliveries I can do, that is T1 and T2, right? T1 is the number of delivery I can do by using a drone 1 and T2 is the number of deliveries I can do by the drone 2 maximum delivery. You can see here I have not considered that this will be raised or I can use another drone or not that time, right? This is the maximum deliveries I can do by the drone 2 and this is the maximum deliveries I can do by the drone 1. Now this total actually gives us that what the actual time I can actually use to deliver any one of them, right? The total T or say total T deliveries I can do, and this T by LCM of this actually gives us the, like when both actually both of the drone actually are taking recharged, will be recharged. So that actually gives us the total actually deliveries I can do. Now I have to check that the total deliveries I can actually do, the total should be greater than equals to D1 plus D2. Clear? This total is the total number of deliveries I can do, and this whatever the deliveries I want to do, D1 plus D2, that should be greater than that. Some of that should be actually greater than total. Clear? This condition is clear. That I have to check that. So three conditions. Let's find out that I have to find out the T1, the total number of maximum number of deliveries I can do by using a drone 1, that will be T minus Ty R1, and T2 is the maximum deliveries I can do by using a drone 2, that will be T minus Ty R2, and total actual delivery I can do, that will be T minus Ty LCM of R1 comma R2. Clear? So I want to, what is the condition to say that I can deliver within T hours? That is condition that D1 should be less than equal to T1. D1 is the number of deliveries I want to do by using drone 1, and D2 should be less than equal to T2. T1 and T2 is the maximum delivery I can do by using drone 1 and drone 2 respectively. So this one D1 and D2, this condition should be satisfied. Next condition should be that how many total deliveries I can do, that is total, that should be greater than equals to the total deliveries I want to do by using the drone 1 and drone 2. This is the D1 is the drone 1 by using drone 1, D2 is the by drone 2. So that sum of should be less than equal to total deliveries I can do. Right? This is actually the available slot. You can see that the total available slot is T, and both will be raised at the time of LCM of R1, 2. Both will be raised, both will be recharged. So available slot will be T minus T by LCM. Clear? So this is available slot, and suppose you can see here that suppose 2, 4, 6, 8. This will be the this will be recharged by drone 1. Next drone 2 will be recharged at the time 3, 6, 9, 12 in this order. Now you can see that suppose T is equal to 1. Can actually use any one of them. Suppose drone 1. Next T is equal to 2. So can actually use drone 1? No, because it will be recharged at the time T is equal to 2. So I cannot use that time. So I can use the D2. Clear? Now T is equal to 3. Can actually use any drone? No, I cannot use the drone 2. But that time I can use the drone 1. Got it? Next T is equal to 4. Can actually use the drone 1? No, that will be recharged that time. So I can actually use the D2 that time. Next is T is equal to 1, 2, 3, 4, 5. 5. At the time T is equal to 5. I can actually use any one of them. Suppose I have used D2. I can be used D1 also. Possible. Both are actually optional. Now at T is equal to 6. Can actually use any one of them? No. Both will be recharged at the time T is equal to 6. So that will be actually skip. Got it? So that's why available slot will be T minus T by LCM. LCM of R1, R2. Clear? This is the total available slot. Or actually I can actually assign any one of them. drone 1, either drone 1 or drone 2, right? So that available slot should be greater than equals to d1 plus d2, the total number of actually delivery actually I want to do. Yeah. So now this, so what is the time history for this approach, this brute force approach? So you can see here that I'm actually checking all the times, like I'm starting from minimum t is equal to 1 to suppose n or 10 to the power 5 suppose. So this will actually take big of n. This is a for loop, because I will check that is it possible to complete within t is equal to 1. If it is not possible, then I go to the t is equal to 2 in this way. So it will take big of n. Now for each time I have to calculate that how many actually delivery actually I can do. So that will be how many delivery actually is it possible to deliver or not. So that will be how many times it will take. It will take big of 1 kind of constant, right? So here actually n is 10 to the power 9 or something, because the time can be large, 2 into 10 to the power 9. So it will give us TL, clear? Because total time velocity is n into 1, clear? N is for this for loop, outer for loop, to set the time, and this big of 1 is to constant time, because this will take constant time that I can easily calculate mathematically. That for t1 it will be t minus t by r1, t2 it will be t minus t by r2, and total it will be, this will all actually mathematical operations. So this will take big of 1. Now to check that it will also take big of 1. So you can see here that we will take big of n into 1, clear? Now can I optimize this? Yes. How? So whenever actually we see any kind of statement, problem statement, whenever actually we have something like minimum time to complete or something like that, okay, that time actually we can think about the binary search, right? Binary search, because it actually optimizes the search space like binary exponentially, correct? Something like you all know about the binary search. Suppose we actually initially we have the search space of L to R, means 1 to 10 to the power 9 suppose. So binary search, how it will work? It will work. It will actually, first of all, I will find out one mid. So this is the mid. So I'll check that is it possible to uh, satisfy the condition by within this time mid, t is equal to mid. So if it is possible, then this is one possible answer. So I will mark this one possible answer. Next is our target is to minimize the time. So or actually we should shift our search space. Our search space should be this or this. So if actually search space, if I shift my search space in the right side, so our time will be more, right? So we will not get the optimal time. So that's why our search space should be shifted to this side, left side, right? So that's why I will shift the right pointer to the here. Clear? Then actually you can see here that our search space is now smaller. Previously it was 1 to 10 to the power 9. It is supposed 10 to the power 5 now. Got it? I have already, because it may possible this is the optimal time. Got it? So that's why I'll store this as an answer in our answer variable. But still we go to the actual left side to get that is there any better solution or not. Got it? Clear? So you all know how many like time velocity for binary search, it will be big of log n, right? And we will call this helper function to check that is it possible to satisfy the condition or not. So it will again take big of 1. So total time velocity will be log n into 1. Clear? If any doubt, you can comment on that. Now go to the code. So this is the function minimum time. So I'll get two vector. One is the d, where is the d0 is indicate the how many deliveries I want to do by using drone 1, and d2 d1 or d2 it actually indicate that how many deliveries I want to do by using the drone 2. And this second vector r, it indicates that r0 it indicates that like the interval of recharging of the first drone, and r1 actually indicates the same for the interval for the second drone. Got it? Now we have written an answer, the minimum time. So I will use it is -1, and I will use the binary search here. So for binary search we need two pointer. One is the left pointer and the right pointer. So left pointer I'll start from 0, and right pointer it is 10 to the power 10. Okay. Now I'll run for this binary search. This while will run till left pointer is less than equal to right pointer. So for this I will get one mid. So I'll check that by using within this time t or mid, can I deliver or I can satisfy this condition or not. So if it is true, that means I can satisfy. So that means this is one possible answer. So I'll store this value into the answer. Answer is equal to mid. Got it? And these are, I'll shift the right pointer to the mid minus 1, right? Because I want to optimize our answer. So that's why I will shift the right pointer to the left side, mid minus 1. Else, if it is not possible to complete or satisfy the condition within this time mid, so that means I have to increase our time, right? Because why should I have to increase the time? Because if I increase the time, then number of deliveries I can do, that will be more. Suppose how many deliveries I can do at the time t is equal to 5. Maximum 5 deliveries I can do, but t is equal to 10. How many deliveries I can do? 10. So this is more probability will be increased, right, to satisfy the condition. So now go to this can deliver function, helper function. So this t1, actually take three things: was the vector of d, vector of r, and the time. Honestly, I'm trying to complete the delivery. So I'll get t1. T1 is the maximum number of deliveries I can do by the drone 1. That will be what? Total number of deliveries I can do, that is mid. And how many times it will be recharged? That will be mid by r0. That will be recharged. So total how many maximum number of deliveries I can do? That will be mid minus mid by r0 by the drone 1. And similarly for drone 2, how many deliveries I can do maximum? That will be mid is the total number of deliveries I can do, and that is it will be recharged how many times? So that will be recharged mid by r1. Clear? So this t1 and t2, it actually indicates that how many maximum deliveries I can do by the using d1, means drone 1 and drone 2 respectively. Now this total indicates what? I have to check that when actually available slot, that means available slot means like total number of deliveries I can do, that actually mid. Within t hours I can deliver to t deliveries, right? So maximum deliveries I can do mid times. Now how many times it will actually occur when actually I cannot use any one of them, like any one of them drone will be all will be recharged that time. So that will be mid by LCM of r0 r1. Got it? That is the time when actually both will be recharged. That will be LCM of r0 r1. Now this many times mid by LCM of this value. So that actually indicates how many times I cannot use any one of them, right? So that means how many times I can use, I actually have some option that will be mid, total number of values I can do, mid minus this number of times I cannot use any one of them. Clear? So these are total available slots. Now what is the condition to check that I can actually satisfy the condition or not? So that should be total maximum number of deliveries I can do by the drone 1, that should be greater than equals to like our expected number of deliveries by drone is d0, and maximum number of deliveries I can do by the drone 2, that should be greater than equals to the number of deliveries I want to deliver by the drone 2, right? These two conditions should be satisfied. Now next I have to check that whatever the available slot actually I have, that is total available slot, the total number, right? So that should be greater than equals to total number of deliveries I want to do within this time, d0 plus d1. Clear? Clear? So if all of these three conditions is satisfied, then I can say that I can complete the like d1 number of deliveries and d2 number of deliveries within this time mid. Clear? So I hope this is clear. I have shared this code in the description, you can check that. And you have any suggestion, anything, you can also comment on that. Thank you. Bye.